All right, let's go ahead and start on problem 2. So I'm working with some data acquisition devices that generate that signal. Let's go ahead and try to move myself over here. I should have actually, I'm going to do that right now. I'm going to utilize some of our resources on Canvas. So I'm going to go to announcements. I'm going to go to exam 1 prep. I'm going to use this notebook. And I'm going to go ahead and get started solving this problem. So we are told data acquisition device generate an analog output voltage. Company claims voltage is normally distributed with a population mean of 15 volts, population standard deviation 1.8. So let's go ahead and start to solve this one. So PDF. So what is the probability of measuring a voltage less than 14.3? I'm going to do integrate. I'm going to integrate my function PDF from values of z. So we less than, so we want to do minus infinity. And we're going to do z function of 14.3. Population mean is 15. Standard deviation is 1.8. And let's go ahead. 0.3869. Excellent. Now we're asked, calculate an interval. So I need the x value. That contains 41% of my data, so we need to do minus x plus x, and that's actually going to be, let's just call this, I'm going to call it z1. We need to solve, when does this value equal 0.41, and we're going to solve it in terms of z1, and that's going to be my plus or minus z, so now I'm going to do solve my, basically, this equals z function of x. My mu is 15. My standard deviation is 1.8. So that would be one value here. This would be another value here where we put minus. There we go. Those are the bounds. What is the probability of measuring a value between 14.1 and 14.9? So I can go ahead and go over here. I'm going to do z function 14.1 and then 14.9. So I'm actually going to copy this here, put it here. 14.1, 14.9, it would be this. What about probability of measuring value between 14.7 and 15.8? So 14.7 and 15.8. There we go. What about the probability of measuring a voltage greater than 15.6? So greater than will be, I'm going to move this just slightly so you can start to, and we'll scrunch it in. So is greater than, so I copied, where did I copy? Copy. I want greater than 15.6. So I wanted to go 15.6 to infinity. And there we go. And greater than that, greater than 14.3. So this in here. Great. Would 14.1 be an outlier? What about 16.7? So remember, we need to take our mean, which is 15, plus or minus 3 times sigma, which is 1.8. So that, anything greater than that will be an outlier. Anything less than this will be an outlier, so none of those are outliers. And that's it. That is question 2. So see you all on the next one. Bye.